Hello wonderful person, this is Anton, and today we're going to be discussing some of the new, somewhat unusual discoveries about our own home, the Milky Way galaxy. And that's because the Milky Way has long served as the fundamental laboratory for trying to understand how all galaxies are born, live, and then change or even die. And since we're sitting right inside of it, astronomers can usually study the galactic structure, the stellar populations, and the stellar dynamics in a lot of detail. But we always picture the Milky Way as a relatively stable, elegant, and even orderly spiral, kind of similar to one of these mini spirals we see in a lot of distant locations. And so based on some of the preliminary observations, researchers actually thought that maybe here we're going to find something else for to somehow visualize it from the outside. But thanks to some of the new massive data sets, and especially the European Space Agency's Gaia Observatory, that simple, comfortable picture has now been officially thrown out of the window. Because in the last few months we've discovered that that's most likely incorrect. Our galaxy seems to be a confusing mess and is a subject to some really chaotic physics, and perhaps most surprisingly, is also somewhat abnormal or anomalous compared to a lot of other galaxies we've discovered in the last few decades. And so today we're going to discuss some of the recent discoveries from the last few months that essentially prove that the Milky Way galaxy is a lot stranger than we ever thought. And though some of these discoveries are a confirmation of something that was assumed to be true a few years ago, some of these discoveries are actually completely unique. And I guess let's maybe start with one of the more extreme discoveries when comparing the Milky Way to some of the other galaxies. And this comes from a project specifically designed to challenge the idea of the Milky Way being typical. This is referred to as the Satellites Around Galactic Analogs, also known as SAGA survey. This was led by researchers from Stanford and Yale, and it was essentially a massive project trying to identify and study 101 other galaxies that are somewhat similar both in mass and even in appearance to the Milky Way. So basically these were what's known as galactic analogs. They were all somewhat similar spiral galaxies, and the goal was obviously very simple, trying to compare all of them to the Milky Way and trying to see what exactly was different. And this was eventually revealed by these 3 separate studies, with each focusing on individual properties. Now, for example, one of the properties was the mysterious dark matter, and here the assumption is based on what we think happens around galaxies. We think that most galaxies form these very massive dark matter halos around themselves that provide a kind of a gravitational scaffolding, preventing galaxies from falling apart and maintaining their shape. And the key way to study these halos was by counting small satellite galaxies that orbit the larger host, kind of like similar to the satellites that we have around us, including small and large Magellanic Clouds. And so here, SAGA survey discovered that comparable galaxies typically have between 0 and maybe 13 observable satellite galaxies. Now naturally they might have a lot smaller ones as well, and ones that are somewhat difficult to find, but when it comes to larger satellites, it was between 0 and 13. And for our own galaxy, we have 4 easily observable satellites, including the 2 largest, which are Large and Small Magellanic Clouds, also known as LMC and SMC. But here there was something that didn't add up. Host galaxies with large satellites like LMC and SMC usually also tend to have way more satellites overall compared to the Milky Way. Yet for some reason the Milky Way contained these 2 large satellites, but overall the number of smaller satellites was much smaller than around other galaxies. And so that was obviously the first anomaly. Second, and perhaps more puzzling, is the state of star formation in all of those satellites. In a typical Milky Way-like galaxy, smaller satellites are usually very active, forming new stars, which is why we usually can see them from pretty far away. But in our own galaxy, only the large companions, once again LMC and SMC, are still active. All of our smaller companions that have been discovered in the last few years, and there are like 50 of them, have essentially completely stopped forming stars and are barely even visible. So pretty much for all of them, the star formation has been officially quenched. And this presents a major puzzle. What exactly happened in the history of the Milky Way that quenched all of these small companions when pretty much almost none of the other galaxies seems to have anything similar? And why is it that only the larger satellites are still active for the Milky Way galaxy, but none of the small ones? And so here, this was definitely something that was a little bit bizarre, because out of 101 galaxies, the Milky Way was the only one with this bizarre configuration. And the central lesson here is quite obvious. The Milky Way is just unusual, and we cannot rely solely on the observations from our own galaxy to build effective galactic models especially when it comes to the formation of stars and evolution of stars, or even in trying to help us understand how dark matter operates. But obviously this is just the beginning, and 101 galaxies is just a very small sample. We now have to look at a full distribution of similar galaxies from a lot of other locations to truly understand what's happening. But some of these mysteries could possibly be explained if we can maybe figure out how the history of the Milky Way was different compared to other galaxies. And so one of the potential explanations for why the Milky Way is different is its somewhat violent history. And in the last few years, there's been a lot of evidence that the Milky Way indeed went through some really major collisions. And so a couple of decades ago, astronomers expected the Milky Way to be in a kind of a stable equilibrium, mostly because it was a spiral galaxy, and we usually expect these galaxies to develop for billions of years. And so some of the initial assumptions suggested that it's unlikely to have experienced some really major disrupting collisions, or at least in some of the more recent history. But a lot of modern analysis and modern maps, especially the ones created by the Gaia telescope, seem to show us a much different picture involving history of violent, aggressive mergers. So for example, this NGC 2808 is a possible old core of what's known as a Gaia Enceladus sausage. A very powerful ancient merger that possibly started approximately 10 billion years ago, which struck our galaxy almost head-on and dramatically thickened the galactic disk. But now some of the recent evidence even suggests that this was possibly a lot more common, and there might have been even earlier collision that was recently identified by studying a group of 20 stars. And these are incredibly ancient stars, billions of years older than the Sun. And so in this recent study, Federico Sestito and the team you see here discovered that some of these stars seem to have a somewhat strange motion. Half of these ancient stars orbited in one direction around the Milky Way, but the other one was orbiting in the opposite direction. And that's something that was kind of unexpected. And the only way to explain this motion is if they were born in a small external dwarf galaxy, in this case referred to as Loki, that possibly merged with the early Milky Way, creating some of these bizarre orbits. But this had to have happened before our galaxy was even fully developed, which means that the merger of this galaxy potentially influenced the Milky Way in quite a dramatic way. And so once this galaxy merged with the Milky Way, it essentially scattered all of its stars in all sorts of directions around our own galaxy, eventually making it part of the central Milky Way mass. And this is of course on top of previous discoveries we've discussed in some of the videos in the description that discuss evidence for several other major mergers, including with a galaxy referred to as Kraken, the galaxy that we still know very little about, and of course a lot of smaller galaxies such as the remains of the Sagittarius dwarf that for billions and billions of years were eventually absorbed into the Milky Way. And most of the evidence for this was only discovered in the last 10 years. Here we have various discoveries of what's known as stellar streams, which obviously have been observed in other galaxies as well, and which represent remnants of ancient galaxies that the Milky Way galaxy eventually stripped apart, leaving behind nothing but just a remnant resembling a stream. And as of 2025, there are at least 30 of them that have already been confirmed. And so this is just yet another sign that the galaxy definitely experienced a lot of collisions. It was never really that calm. But its violent past is actually most visible in this other feature that was only recently confirmed once again. This is one of the most dynamic and unexpected recent findings when it comes to the Milky Way galaxy. A gigantic wave or a gigantic ripple spreading across the galactic disk. And this enormous structure was identified by tracking precise positions and movement of thousands of young bright stars by using the Gaia telescope. And here researchers confirmed vertical distortions, or also known as corrugations, that essentially ripple through the galaxy at distances between 30 to 65,000 light years away from the galactic center. And this actually covers an enormous fraction of the entire galaxy. And this was most recently reported in a study by Poggio and the team you see here, with a study just simply named the Great Wave. And so this galactic wave is somewhat similar in appearance to a typical ripple, especially if we were to somehow look at the galaxy from the edge. And it basically forms a kind of a complex galactic warp. But what makes this particular new study kind of unusual are of course the details of the motion that nobody knew about before, because apparently the wave is also propagating outwards and away from the galactic center. So here the structure is consistent with the wave moving toward the outer edges of the galaxy. And second, and that's actually the really unexpected part, this wave does not just involve vertical up and down movements, and instead the stars located in the crest of this ripple are also exhibiting systematic radial motion or basically they're being pushed outwards at the speed of 10 to 15 kilometers per second. And for a typical galaxy, that's kind of high, and actually very, very strange. It's as if something is pushing all of these stars away from the center, just like what you would expect from a typical ripple on some kind of a body of water. And normally we assume that vertical motions and radial motions are supposed to be disconnected, but in this case observations strongly suggest a direct link. This wave definitely appears to have upward and outward movement simultaneously, and that's super strange. As a matter of fact, it's somewhat similar to a physical phenomenon referred to as the Rayleigh waves, something that we normally find in fluids like ocean waves, where the movement of the material itself involves transverse and longitudinal components. And if so, then there's this new question. So, what triggered this? Because this is a massive ripple, so what exactly happened here? Well, here one obvious answer is once again some kind of a ridiculously powerful collision. But the thing is, this could also be related to some kind of a complex internal mechanism we still don't understand. And so whatever caused this great wave, it definitely shows us that the Milky Way disk is still dynamically active and currently experiencing very large perturbations, and the galaxy is far from being still and calm as we initially thought. And so here this confirms that the story of our galaxy is not one of quiet stability, and instead seems to involve complex continuous evolution and a system that's shaped by ancient aggressive mergers that even today still seem to cause some kind of an effect by creating these large outward propagating waves. And by the way, this might also explain one of the recently discovered mysteries by Harvard University scientists involving this really massive wave not so far from our own solar system. You can learn about this in one of the videos in the description. But I guess the fact that our galaxy is also a cosmic outlier and seems to be different from other similar galaxies creates additional mysteries that we just cannot explain right now. Which means that we cannot use the Milky Way as a kind of a template to try to explain the rest of the cosmos, and we also must continue studying other galaxies to truly understand fundamental physics and to try to understand dark matter and galactic evolution. But because of a lot of these surveys and a lot of these recent observations, we actually do have enough data now to start making some conclusions, which means that in the next few years we'll probably be seeing a lot of these new studies trying to essentially figure out what exactly is happening here, or what happened to the Milky Way for billions of years to make it so strange. But in this case, it's really this complexity that makes our galaxy so super fascinating. And so we'll definitely come back and discuss this more in some of the future videos. Until then, check out previous videos on the Milky Way in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. Alternatively, you can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.